Okay, let's get started. Welcome everyone to today's second session on proposed Euro 7 legislation and test and measurement solutions. My name is Jamie Disher. I'm from HORIBA Europe Marketing. And before we start, I would quickly like to walk you through our terms and conditions. Firstly, this webinar will be recorded. However, we have privacy settings to ensure privacy for all our participants, so you cannot see who is participating, and neither will it be visible in the recording. Second of all, we have a chat function on the right-hand side, so if there's any questions during the webinar, feel free to drop them in the chat. I will read them and save them for our Q&A session after the webinar. And also, if there's any difficulties we can help you with throughout the webinar, also feel free to just drop us a message. And then, as I said, the last part of the webinar after the presentation will be a Q&A session with our two experts where you get the chance to ask questions in the chat. And I, in return, will pose them to both of them. And without further ado, I would like to get started. Today's experts are Les Hill, Automotive Technical Fellow here at HORIBA, as well as Ollie Meller, Digital Solution Commercialization Leader, also at HORIBA. All right, Les, it's up to you now.
Thank you very much, Jamie. Thank you. Good afternoon or good morning, depending where you are at the present time. I would like to kick off with the proposed legislation and really just focusing on the published Act and Annexes for Euro 7, but there will be some updates from recent agvez meetings, which is progressing the Euro 7 development. Before I get to Euro 7, there's obviously been some key activities in the automotive area that will affect what will happen in Euro 7 and impact. This is the European Green Deal, and the European Green Deal, which has been passed through the European legislation process. When we look at the key actions, you see when it comes to things like fuel consumption, we've got the revision of the CO2 emissions performance for light-duty passenger vehicles and light commercial. We've got heavy-duty CO2 reduction proposals, which were announced on the 14th of February. And of course, now we've got the Euro 7, which is this proposal for more stringent air pollution emission standards, which was actually announced in November 2022. The background, the Fit for 55 package will require that light-duty cars and vans must reduce their emissions by 55% and 50% respectively from 2030, and 100%, in other words, no combustion from 2035 in comparison to 2021 levels. That has been now approved by the EU Parliament on the 14th of February. It will now go to a final vote in plenary, and it will have to be endorsed by the Council. Now, my understanding is that vote from the Council, before it goes into the published in the official journal, will take place on the 7th of March, but it is expected to go through. These are the details of the heavy-duty CO2 reduction that was published in February. Basically, for heavy duty, all trucks above 5 tons, city buses and long distance buses above 7.5 tons, as well as trailers, they have to meet a reduction of 45% against the 29 levels by 1st of January 2030, 65% by 2035, and 90% from the 1st of January 2040 onwards. New city buses will all have to be zero emissions as of 2030, but you can decide how you will meet that, because you could use electrification, hydrogen fuel cells, or using hydrogen and internal combustion. There will be exemption to the CO2 reduction targets for this list here of heavy-duty vehicles. I've lifted this slide is courtesy of the UK SMMT, which shows how the timing has changed for Euro 7. Euro 7 was a long process taking over 3 years, which concluded in what was called the agvez Advisory Group Vehicle Emission Standards, which on the 27th of April. Now, this was the assumed timing. Unfortunately, this was much extended. we expected the announcement to be made on the 14th of December. It was actually delayed till the 10th of November. So what happens in this original schematic here of the co-decision followed by implementing has been severely compressed. This didn't happen as originally planned, and that has enforced a change into the process. I show you here the published act and the annexes. This is just so you can reference. These are public documents. You can download them, and this will give you the full details of what's been published so far. Now, the EU7 standards is a bit of a revolution in terms of automotive regulation. For the first time, we have a coverall regulation that not only covers exhaust emissions and evaporative emissions, it also covers other areas of emissions in the car. So, for example, we now have limits for the emissions from brakes. They are proposing rules on the emissions from tires. And also the testing is going to be significantly different than it has for Euro 6. The emissions will have a longer lifetime. They must meet the requirements, more effective tests, digital monitoring of the vehicle for compliance. And the other changes will be, we've got fuel and technology neutral emissions limits, we've got new pollutants, and we've got the on-road test with a broader range of driving. And finally, Euro 7 also covers electric vehicles, specifying battery durability requirements, which was not part of the original agvez, but was added to Euro 7 by the European Commission. The type of testing, as a result of the agvez process, the favoured route for type approval will always be on-road testing. That is, you take your vehicle that you wish to be type approved and you drive it on the road. The emissions equipment is mounted, the portable emissions measurement system is mounted on. And now the rules will cover almost all driving conditions in terms of dynamics, cold starts, warm starts, and a wider range of ambient temperatures and payloads. You are also expected to measure the new regulated pollutants if it's technically possible to do so. Laboratory testing is still in the type approval, but this is mainly for using the WLTP for CO2, for the fleet-based CO2 emissions targets. However, if you're unable to measure the new regulated pollutants on board because you don't have the technology, you can do the testing in the laboratory. But that will be using some form of RDE test cycle, the form of which we're not exactly quite certain. Low temperature testing will be performed at -7 according to the requirements of GTR 15. And the third element that is really quite also enlarged is the expansion of market surveillance and in-service testing. So conformity production is already, of course, there, and in-service conformity testing is also included. But there'll be more increased market surveillance by using the onboard monitoring, which I'll talk about later, and remote sensing. And also there's going to be a regime of supplementary RDE and laboratory testing by member states, the EU Commission itself, and accredited third parties. The EU7 standards, there are basic EU7 if you meet the requirements, but there is also derivative standards. The 7+ means that you have a vehicle that's got lower emissions or a higher battery durability, and that goes for an electric vehicle as well. A 7A means your vehicle is equipped with adaptive control functions, and the definition of adaptive control functions is given at the bottom. One of them could be, for example, that you have a system where your sat-nav will tell the driver to cruise or coast as he comes up to the next road, roundabout or junction, in which case the engine will shut off, and that will save pollution and will also save fuel. So that could be an adaptive control. 7G is defined for vehicles which have got an internal combustion engine with geofencing technologies that stops the engine operation if it's got a depleted battery in urban zones. And you can combine all of these different categories to give you a combination category of type approval for your vehicle. This is the specification for what would be an EU7+. you have to declare, and of course, if you declare compliance, then it will be verified by in-service conformity or other means, that you have a 20% lower emission limit than those set out in Annex 1 for gaseous pollutants, and an order of magnitude reduction for particle number. For a plug-in hybrid, then you have to have the 20%, and you also have at least 10 percentage points higher in terms of the durability of the battery than the standard. And for a pure electric vehicle, you have to declare a battery durability at least 10 percentage points above that of the standard. Other big change in Euro 7 is the inclusion of onboard monitoring. Now, onboard diagnostics has been around for a long time, but the onboard diagnostic system does not fulfill the requirements of Euro 7. It may not give a full accuracy of what the emissions are or any malfunctions, and it doesn't force repairs. But the intention is that onboard monitoring of the emissions of the vehicle will be used, and that will be logged by the vehicle, and it can be informed over the air to a central area. The EU Com has confirmed in the recent meetings that the onboard monitoring will include sensors for NOx, ammonia, and PM. Now, some of these sensors, or these sensors, do not work from cold start, so they have to warm up before they become operational. So in that case, modeling or virtual sensors will be applied for these cold start periods. One of the interesting applications, and by the way, just to say that all vehicles must have an effective proven onboard monitoring system before the 1st of July 2025, which is the introduction date for Euro 7 for light-duty vehicles. The OBM is going to be used to bring up the excess emissions driver warning system. EDWAS, it's a terrible acronym for light duty and heavy duty. And this is a traffic light warning system that will give the driver information about his emission status. Effectively, it's a traffic light system. If you have the green, and this display is shown to the driver at the start of when he starts the engine and when he stops the engine. That was the intention. So basically, if you're green, everything is okay. Emissions are all okay. Everything is normal. The monitoring is normal, which means this vehicle is available for testing for in-service conformity. There's an amber setting, which is inconclusive monitoring. In other words, probably okay. Vehicle is not a high emitter, but the OBM monitoring for some reason is inconclusive. That could be because it was halfway through a regeneration. The trip wasn't long enough for the onboard monitors to make a decision on its operational status. So you'll get an indication of that to the driver. And of course, the worst case is the red. And this is where the emissions are probably not okay, or the OBM is faulty, in which case the vehicle is not suitable for in-service conformity testing, and inducement must be triggered, which basically means telling the driver you have a problem. And there will then be stages of inducement, which would ultimately, in the worst case, mean the engine would not start. But that's all in discussion at the present time. Here are the limits. These are the limits for the light-duty vehicles. And what you see here, everything in pink is new. This is new from Euro 6 Step E, which comes in September. And basically, they've harmonized the emissions at the EU 6 limits. That is the lowest of, so everything is at the lowest level for Euro 6. It's the same for gasoline and diesel. The same results apply for laboratory testing and on-road. There is no uncertainty factor for the PEMS. The PEMS is assumed to be accurate within these limits. We have new emission species. We've got new ammonia as a mass in milligrams per kilometre, and particle number is now 10 nanometers, not the current 23 nanometers that are in Euro 6. Now, there was some surprise with these figures. They were not as low as what was proposed by the working group, the contracted to agvez. However, if you read the impact assessment, the Commission decided not to impose lower limits in order to give the manufacturers enough time to engineer for the more stringent Euro 7 requirements. And that's explained in the impact assessment, which has been published. Now, when it comes to the actual limits, you'll see that here there is this new column. It's called the emissions budget. And the emissions budget applies to all testing that is less than 10 kilometers. If you start a vehicle and you drive for less than 10 kilometers, then you're allowed to emit 600 milligrams of NOx. That goes for all components, by the way. This example just shows the NOx, which is 60 milligrams per kilometer. So for 10 kilometers, you have a budget, 600 milligrams of NOx. Now, in order not to be reasonable, the EU7 proposes that for the first 2 kilometers, you have a power restriction on the vehicle. So that's to stop people who start the engine, drive away at full throttle from a cold engine. You can't do that. That is an extended condition. So for that reason, they have this 2 kilometers of restricted power driving. Now, how is that detected? Well, the CLOVE proposes using the PEMS is connected to the onboard diagnostics, and that will be indicating what the power of the engine is, of the maximum wheel power from the vehicle. That will be indicated. If it's a plug-in hybrid, then it's 2 kilometers after the first internal combustion engine start, not the vehicle start, because obviously a plug-in hybrid could start on electric. The emissions limit area covers all this emissions limit covers all conditions, normal and extended, which I will come to. But effectively, if you're in extended conditions, you divide the emissions by 1.6 to reduce it. But that's only for the parts of the test where a single parameter is in extended. There is discussion about what happens if there's more than one extended condition at the same time. And also, just a note here about using the OBD link. Previously, it was not encouraged for the PEMS to use the OBD link in case it was possibly used for some kind of defeat device. It's now been accepted that this is extremely unlikely to happen because of the number of testing that's performed throughout the type approval and also in service conformity. It's very unlikely to ever happen. So I just put this slide in. This was one of the slides from the CLOVE consortium, and it looked at the different options of how you could reduce the power for the first 2 kilometers, and they came up with the normalized average wheel power. And the explanation of why they preferred that method is given here. So when we start the emissions testing for RDE, here are the parameters for the operation of the vehicle on the road. These are the parameters here. The ones in pink are new or modified from Euro 6. These are normal driving conditions, and here is the extended conditions. So the trip composition is anything. There is no requirement for average speeds or urban rural motorway or engine stop, nothing at all. It is whatever happens. There is no driver behavior limits aside from the first 2 kilometers. There's no target distance or time duration, which is an issue because that will affect the battery capacity for the PEMS. Any periodic regeneration is included, and there will be a mechanism by which the higher emissions during regeneration will be amortized through the rest of the vehicle operation. We now go for normal temperature is 0 to 35 instead of 30 degrees. Extended goes from -10 instead of -7, and extended to 45 degrees instead of 35. And the altitude is also extended to 1800 meters. Testing requirements. Well, there's a lot of question marks on here, and the reasons are the open questions you see below. So for RDE testing at the moment, you have to measure all of the components. The only one that was included in the Act and is no longer necessary is real-time PM, because of the technical issues of actually determining real-time PM on a vehicle is very difficult to do. The reason that THC and non-methane hydrocarbons have got question marks is because these would be measured using an FID. If you have an FID, you must have FID fuel, which is a hydrogen-based compressed cylinder. So what you would finish up with, there are certain member states that do not allow the use of compressed flammable gas on board a vehicle. So in this case, then if you could not measure these on RDE, then they would have to be measured in the laboratory using an RDE type cycle. For RDE cycles in the laboratory, obviously you can measure everything. There's no problem at all. To do the fuel consumption, strictly speaking, it's not necessary to measure NOx, PN, non-methane hydrocarbons, because you can measure total height. You can measure all of the carbon coming from the fuel to determine the fuel consumption. But we expect that the Commission will expect all of the emissions to be tested during the fuel consumption testing. And also, we now know that there will be a requirement, even though the RDE test covers -10, there will be a requirement for low temperature testing, which means all of these will be required to be measured in the future. Just a graph here showing how the new Euro 7 limits compare with Euro 6D positive ignition and Euro 6D compression ignition. That's gasoline and diesel. And you can see they've all been harmonized to the same low level. The only new requirement is the ammonia, which is shown here at 20 milligrams per kilometer. Moving now to heavy duty vehicles and engines. So again, the predominant intention is that heavy duty vehicles are tested on the road. However, of course, some engines are used and sold for heavy duty vehicles, so they have to be tested as well, but they have the same limits. So anything in pink is new. So we've got PN 10 nanometers, we've got NMOG, ammonia, methane, nitrous oxide, and formaldehyde. And again, we've got an emissions budget, and we have cold emissions and hot emissions. Now, there's also a new requirement for optional idle emission limit, and this is only for NOx, and this is applicable if your heavy duty vehicle does not automatically shut down the engine after 5 minutes of continuing idling. In that case, there is a limit here of 5 grams per hour. Now, same rules for there's no conformity factor for RDE on certain from the PEMs, and we have these new species, and we do have an emissions budget approach in the same way as light duty. Now, for heavy duty, it's a fairly complex scenario. The budget applies for 3 times the amount of work during a WHTC cycle. So typically, if the engine is 200 kilowatts, then for a WHTC amount of work, it would be 40 kilowatts. So for less than the 3 times the WHTC, that's the budget. You cannot exceed the budget as given in the table. Anything above 3 times the amount of work from a WHTC, then you're limited by measuring the 90th percentile of the moving average windows. Now, when you have the emissions, the worst case conditions here, what you have is when you do the moving average window, typically on a normal, your highest emissions will be during cold start. So when you do the first moving average window from a cold start, that will normally be the highest emission, and that must be less than the 100th percentile shown in the cold start. Once you've gone past that, then the average normal limit is the 90th percentile, so you must be monitoring after that. Now, it may be, most of the time, it will be the cold start that gives the highest moving average window value, but there are maybe circumstances where it would not be the case. Now, if you're in extended conditions, whereas a factor of 1.6 was used for light duty, the factor for heavy duty is a factor of 2. But that's only applied again for the parts of the test where the parameter is in extended range. Now, this came up in a recent meeting, and what if more than one extended condition? And one of the discussions was that the data would be logged but not used in the final calculation. So these are the conditions for testing on the road. And again, all of these are actually new for heavy duty in comparison to only the few that were changed. Normal driving conditions are given here, and extended driving conditions are given here. Again, in Euro 6 heavy duty, the trip had a certain format. Now it's any trip composition, and it should be related to the normal use of the vehicle when you consider its purpose. So therefore, an urban bus, the trip should be largely stop-start, as you would expect. If it's a long-distance truck, then elements of long-distance operation would be included. There's no trip distance or duration has been specified. And again, periodic regeneration emissions are included. Extending temperature range from -10 and extended up to 45 degrees for the extended range. And the altitude extended condition now is 1,800 meters, which is obviously an increase over Euro 6. So again, very wide open conditions on how the heavy duty vehicle is tested on the road. When testing the engine for the testing requirements for the heavy duty, well, you've got the RDE test, and here are all the components that must be measured. Now, okay, again, as I said, real-time PM is no longer required, so this is now deleted. When you get into the laboratory, they propose to validate the engine, then you'd use the cold and hot world harmonized transient test cycles plus brake-specific fuel mapping for Vecto. And the question is the world harmonized stationary cycle actually necessary? When you're testing your engine, all fuels that are applicable to the engine must be tested. So diesel, CNG, hydrogen. Hydrogen will be included in Euro 7 because this is hydrogen internal combustion is now currently going through UNR 49 at the present time. It was presented at GRPE in January this year. NMOG is the parameter for hydrocarbons, and in this case, the proposed calculation for NMOG was confirmed or proposed in the last agvez meeting, and the proposal is that you can determine NMOG using total hydrocarbons, methane, and formaldehyde. Now, the calculation originally for NMOG comes from USA EPA CFR 1066, but it's a much more complex procedure because it involves the measurement of ethanol and the measurement of 13 oxygenated hydrocarbons, which is quite complex. And there's no analyzer that does it. It has to be done with chemical measurement. But also they've suggested a new equation which only uses the three compounds of THC, methane, and formaldehyde, and uses the fuel oxygen contents. And this is the formula that's been proposed. They've also submitted a calculation that can be used for fuel oxygen content and density. And basically, if you're using standard fuels, then you can use the standard values. Now, of course, if you wish, you could analyze the fuel to get the detail. But what they're saying is as long as your fuel meets any of these standards, then you can use the default values for those fuels to use in the calculation. And the proof of the pudding for the calculation is when you compare the proposed EU NMOG calculation with CFR 1066 NMOG. And as you can see here, the correlation is really good. So basically, this is showing that if you took what is the abbreviated NMOG, which is just based on those three components, THC, methane, formaldehyde, gives you a good result as taking all of the measurements that are required under CFR 1066. This is just a slide that shows the testing required for laboratories for heavy duty. So this is your world harmonized transient cycle. You can see the cycle here. And so it will be tested according with regulation 49. For fuel mapping, as I said, is required to be put into the European Heavy Duty Vehicle Emissions Modeling Program called Vecto. So here's the fuel mapping cycle here. And I think the proposal in the last meeting was that the emissions will be measured during the mapping cycle to check that they conform with the limit. Now, Currently, for Euro 6 heavy duty, you have to perform a world harmonised stationary cycle. The EUCOM did not propose this as not being necessary. And also the world harmonised not to exceed test, which is part of Regulation 49, they're saying effectively can be replaced by the on-road testing. When we come to the EU Commission accepted there are special conditions for small and ultra small vehicle OEMs. So basically they should get some kind of derogation from Euro 7. So a small volume manufacturer is someone who produces less than 10,000 motor vehicles, 10,000 M1 vehicles or 22,000 N1s, and is not part of these excluding conditions like being part of a group of connected manufacturer or a bigger manufacturer. Ultra small vehicles who produce less than 1,000 new vehicles of M1 or N1, that would give you ultra small manufacturer classification. These are the rules for small volume. Basically, you can set out declarations of conformity. If you're a small volume manufacturer, you can simply say, we declare we meet, but the compliance will be tested by in-service conformity and market surveillance. So it's not safe to simply declare without knowing that you can meet. Ultra small shall apply with the limits set out in the annex in laboratory tests based on random real driving cycles for in-service conformity and market surveillance. So in other words, the word random was used here, and the random was a qualification that is still under discussion. Did it mean random? Does it mean simulated? Or can it mean replication of an actual R&D trip that would be performed on that vehicle? So that is still to be discussed at the moment. There's also special rules if you are producing multi-stage vehicles. These are vehicles which are produced using a standard powertrain and chassis from another OEM. And for multi-stage vehicles, the final vehicle, anybody who manufactures the vehicle is responsible for the emissions type approval if they make any modifications to the vehicle beyond the data provided by the manufacturers of weight, frontal area, and all sorts of these kind of characteristics. If you stayed within them, then the responsibility for the emissions stays with the manufacturer of the previous stage, such as the chassis and the engine. The Commission will insist that the information is given so that the criteria and the parameters for meeting will be given to the subsequent stage of multi-vehicles so they can stay within that, which means the original engine OEM is responsible for the emissions. As well as exhaust emissions and the other changes in Euro 7, you've also now got a more stringent evaporative emissions test, which now includes, for the first time, following the USA and China, onboard refueling vapor recovery will be also tested in the evaporative emissions. There is now proposed limits for particles from brakes, dust from brakes. Currently, there is obviously placeholders here, but the first values which have been put in is that up to 2030, end of 2034, you should not emit more than 7 milligrams per kilometer of PM10. Other parameters are still yet to be established. And from 2035, that would be reduced to 3 milligrams per kilometer of PM10. The test method is based on the UN GTR draft method. Now, in this case, when you look at the draft method, it's more than PM10 and PN. It actually includes PM10, PM2.5, PN of 10 nanometers, and total particle number. So even though the EU7 requires these as limits, they're expecting to see all the measured parameters when the brakes are tested. And this is just the background now of the work through of the document. One of the issues is who is responsible for the type approval of the brakes. Is it the vehicle manufacturer or is it the brake OEM? And what happens if, what happens if it's a mix, that someone provides the disc and somebody else provides the brakes? Who would be responsible for type approval? The latest comment I heard is that, to simplify it, it's probably going to be the vehicle OEM who's responsible. But then again, that is just a comment. It would need to be confirmed. Oh, and just a point, they're also requiring testing for COP and in-service conformity for the brakes was included in the draft act. Tyre abrasion is also included. This is emissions from tyres. And currently, these are the categories that are included in the act. These are for the different types of vehicle, from C1 to C2 to C3 tyres, normal, snow and special use. No values. This is just a placeholder in the Euro 7 Act. And the question is, there isn't actually a method at the moment. There is a new UNECE task force that is looking into this for tyre abrasion at the present time. So when that comes in, then the method will be included in the implementing acts. So they're saying agvez concluded that it's responsible of the tyre OEM to perform this type approval. And so tyres must be tested. And of course, if you've got an EU7 type approved vehicle, then your tyres would have to remain as EU7 compliant. Here is the requirements for the battery durability minimum performance. These are the values inserted so far. So for a 5-year, 100,000 kilometers, we're looking at 80% for passenger vehicles and 75% for light duty commercial vehicles. This is reduced again if you go beyond that to go to 8 years and 100,000 kilometers, you get a reduction here. At the moment, the other values are still yet to be established within. Now, it says here there's two categories. One is the energy-based minimum performance, and the other is the range. From my understanding is they are linked together. Obviously, the range does depend on the battery. The test method is already basically confirmed in UNR GTR 22. And so that will be adopted and modified as necessary for the purposes of Euro 7. Tampering. Now, obviously, when we have emissions control systems, we all know that there are places where they can be tampered and modified. Heavy duty, having the SCR removed and fitting. We have remapping of the vehicle, which can also increase the emissions. And there will be rules within EU7 and tests to make sure that that doesn't happen. Under Euro 7, it will not be allowed in any form, and it will be detectable if someone has tampered with the vehicle. All of that will be included within the Euro 7. So if we look now at the timeline, so we start here when the European Green Deal came through, then the Fit for 55 package, agvez running underneath here from 2018 onwards into 2021, then the impact assessment, and then we've got agvez starting again. Now, the Euro 7 proposal is shown here. Now, we remember that we get the Euro 6E light duty comes into force in September this year. And they're proposing that the Euro 7 comes into force for light duty vehicle on the 1st of July, 2025, only 2 years after Euro 6E comes in. Heavy duty Euro 7 comes into force in July 2027. And here are the application dates here for the small vehicle and the the small vehicle OEMs. Now, we have compressed the process. Originally, the Parliament and Council would be reviewing it before it went to implementing regulations. However, because of the extended time from original proposal, the two processes are running simultaneously. And they're not expected to be concluded fully until spring of 2024, according to the EU Commission report to the EU Parliament. And the other thing to remember is that it's not new type approvals from 2025, from 1st of July. It's all vehicles, including existing ones which were approved under Euro 6E. So the work on the implementing regulations has begun. And in the first meeting, the EU Commissioning opening statement is that agvez is not here to decide the content of EU 7 and its timing. It is only here to work out how it can be met. The Act and the annexes can only be modified by the EU Parliament and the Council of Ministers. And of course, this caused a comment from industry saying we are effectively we may be implementing acts on a moving target, and that is of some concern to the industry, given the short time period before EU 7 becomes applicable for light duty. Here's a review of these. Are a list of the agvez meetings, which are ongoing. We had the meeting last week, and some of the material I show today is a result of that meeting to show progress. Now, the dates have been extended. You can see what is happening on all of the dates. They're very clear. Anti-tampering will be done on the 17th of March. And the dates now have been extended, realizing the amount of work required. They've extended dates towards the end of 2023. This is a slide from Clove shown in the agvez meeting, showing that when it comes to the formation of the implementing regulations, they're not starting with a clean sheet of paper. They're going to start with existing regulations that will be modified as necessary for Euro 7. So if you take the case of light duty vehicle, the current Euro 6 is 2017-1151, will be supplemented by GTR 22 on battery life with UNR 85 and GTR 21. Heavy duty will start with the current EU 6 heavy duty, 582-2011, with UNR 49, GTR 22B. So basically they have a starting, it's not a blank sheet of paper. They can bring together and compile these regulations that would go into Euro 7. And there are also existing regulations for things like anti-tampering. OBD and OBM would based on 1151 to start with and then extend on that. Even tire abrasion, as I said, there's a United Nations task force on tire abrasions, which is starting work at the moment. This is the table of contents for the implementing regulations that need to be defined. And these are lists that they follow. This is only a tentative list. They think they've covered everything, but there may be changes in this as the implementing regulation evolves. Then there may be additions to this or maybe even reductions from this. And this is the annexes. The annexes are the technical details. For example, the verifying real driving emissions, the performance for the test equipment, the accuracy requirements for the test equipment will all be covered here as annexes. And these are the preliminary annex for heavy duty vehicle implementing regs. So these are specially reserved for the heavy duty vehicle testing. So here's your next steps. They're targeting that they will have the final draft text by September 2023, which would be very good if they could. HORIBA personnel were participating in all the agvez meetings, and we also participate in small specialist working groups, for example, on testing and measurement topics as well. So to summarize, a lot of change for Euro 7, a lot of issues. It's a challenge. It's a challenge for the legislators to complete this, and it's certainly a challenge for the manufacturers. So there's a lot of change that will come with Euro 7. And I believe we now go to a survey. So which part of Euro 7 will be the toughest to meet? So please, if you could put your votes in for this, and we can have a look at the results. Thank you. So we have quite a wide variation there. EU 7 light duty performance data seems to be seems to be the most predominant issue of concern at the present time. Thank you for that. So, thank you for that, for those results. They'll be very interesting. We're going to go quickly to testing and measurement solutions. And I must stress, this is really brief. Because of the limited time, we wanted to make sure you understood the status and process of the Euro 7 legislation. We want to use some time to look at the testing and measurement solution. So this is very brief. First of all, one of the changes is PN10, or solid particle 10 nanometers, and we have we already have the instrument in the laboratory which will do this, which is the MEXA 2x10 SPCS. This is following the description of the modified method, which is in this document at the bottom. Basically, we've changed from the evaporated tube that was used to a hot catalytic stripper. And what you see, we've also changed the CPC, and now CPC is no longer optimized to measuring 23 nanometers. It is optimized to measuring 50% cut point at 10 nanometers. This instrument is available in two versions. You can get it for CVS diluted exhaust and also for measuring tailpipe row exhaust is also available. And existing SPCS systems for 23 nanometers can be upgraded for the new 10 nanometer standard. Now, this would be for 10 nanometers. If you still want to have some data about 23 nanometers, then you can put an optional second CPC optimized for 23 nanometers onto the new SPCS. For onboard SPCS, for onboard PN, we have the SPN10, the OBS1 SPN10. And this is basically a development of the existing OBS1 PN, which was for 23 nanometers. And basically, this is following the requirements. We're still obviously using a CPC because that gives the best results. And you can see here on the graph, you can see the way the response has been changed from the 23 nanometers to the 10 nanometers. Now, it's very similar to the existing OBS1 unit, but it has been considerably modified internally in order to reduce the amount of losses, because 10 nanometer particles are lost much more easily than 23 nanometers. So that's been reworked, but it's similar in the way it's designed, the system configurations and the user interface. We have a variety of pre-described optional lines that you can use to allow you to install it where you need to do. And we've added an automatic zero check function, which is going to be part of the new regulations, for which we have a patent, which is currently pending. Now, one of the interesting from the last agvez meeting was the attitude towards new analyzing techniques. So 2 new analyzing techniques have been recognized as having potential for Euro 7. One is the quantum cascade laser, and the other is the Fourier transform infrared. Now, basically, these are already defined for measurement of certain components like nitrous oxide and ammonia. But in the meeting, it was suggested that these analyzers are also able to measure currently regulated gases like CO and CO2 and NOx. So basically, they're going to look at the text that would allow these analyzers to be used not only for the new regulated pollutants, but also the existing ones. So here is an FTX. We have 3 models of the new FTX1. This one is literally just an FTIR for use with raw gas. Then we have the same device, but fitted in and with the RS model. And the RS model can incorporate THC with a FID and oxygen by magneto-pneumatic. And finally, we have a new version that could be used on CVS. And this will actually measure for Conti dilute and also bag as well. And that may be appropriate for some people who do want to continue to use the CVS system. We also have our QCIIR technology. Now, I've put this schematic in for people who may not be familiar with the use of mid-infrared. So you've got the NDIR, which has been around now for some 70 years almost, which is the conventional infrared, where you have a light source, what we call a wide emission spectrum source, and the selectivity comes from the optical filter and the filling of the gas detector. And typically that analyzer will measure one component, although it can measure more with certain designs. FTIR takes an infrared light source and then from the interferometer creates a sweep of infrared wavelengths, which goes through the test cell into the detector. And then it gives you an absorbance spectrum over the range of the wave, and that we can calculate a large number of gases from a single measurement on the FTIR, and that gives you multiple gas. QCIIR is using a very high precise wavelength emitting, mid-infrared wavelength lasers. And for this, typically, you may have one laser for each gas, and these are fired sequentially, so that as one fires and then measurements taken, then the next, and it's done very, very rapidly. And so for each laser, you'll get a peak of measurement. So typically one gas per QCL. But the beauty about the QCL is the fact its design is very suitable for onboard. There's no moving parts like moving mirrors. There's no liquid nitrogen. It's very robust. It's very compact. So it makes it very suitable for onboard measurement. Now, in fact, we've been introducing QCIIR analyzers into products now for some time. We have this is an updated model of the NX, which replaces the previous model, measures these 4 nitrogen compounds. We've also integrated nitrous oxide as a dilute measurement into a MEXA 1. And we also have formaldehyde, which is available to be installed in raw or diluted exhaust as well. And we've also introduced now the OBS1 XLO1, which measures nitrous oxide and ammonia. And the performance of this analyzer is described, and its suitability for onboard measurement is described in this SAE paper that was published 2 years ago. So when asked the question, I want to start testing for EU7 now. Well, unfortunately, we can't do formaldehyde in this version, but we can do ammonia and nitrous oxide. So you can combine the existing OBS1 GSO2 providing these gases with the OBS1 XLO1 providing these 2 gases, which covers ammonia for light duty, and you have the OBS1 PN10, which is again available to be used now. Now, in future, we are making more developments of QCL. And what we're working on at the moment is a PEM system that works entirely with QCIIR technology, measuring all of these compounds. So these 8 compounds can be measured using QCIIR. And in certain cases, we're able to support 2 ranges. One of the problems with the existing OBS was the low CO measurement, very low CO. Now we have 2 ranges that we can support. We also have 2 ranges as well for methane. And this covers a normal range of methane measurement for a normal engine. And this will cover methane emissions from a CNG fueled engine. And these are both built into the system. Now, at the moment, design work is still going. We have tested the prototypes and getting very satisfactory results, but we're still doing the design. For full work, you will still need a fin analyzer because we still need total hydrocarbons. And the only way we can do it with sufficient accuracy at the moment is by using an FID. This is just some graphs showing you the performance when we've compared the QCIIR with other analyzers like a FID and against FTIR. And you can see we've got very good correlation, and we also have confirmation that a high range will be necessary if you're running on CNG fuel. But you can see the linearity is very good in comparison with the existing techniques. Similarly with nitrous oxide, very good correlation, and we have a better sensitivity with the QCL method. It's much more stable and more sensitive. and gets a very good response. Ammonia is a very difficult gas. Anybody who works with ammonia knows it's really not easy. It is very susceptible to the sampling system, but we have, again, very good correlation. And although ammonia is a very sticky gas prone to slow response, the Erlen response is faster, which is very good and bodes well for its application in the future. And finally, one of the difficult gases to measure because of its solubility and instability is formaldehyde. So this one, you can see the fitting is a little bit more difficult, and that's simply because it's a more difficult gas to measure. But we've got pretty good correlation, and we've got a much faster response time than we have with the FTIR by using the QCIIR method. Now, very quick look at a possible light-duty cell. In our opinion, the CVS remains the gold standard for accuracy and repeatability. It still is the best method, and certainly will be the method that gives the most accuracy for CO2 and fuel consumption measurements in the future. So here typically is what you might have looking at the present. So you'll have an ammonia analyzer, probably measuring from raw exhaust. You may need some form of exhaust flow meter. Now, we're showing here an ultrasonic flow meter, but how you measure the exhaust flow rate could be a variety of methods. You could use the exhaust flow meter from the PEMS. You may be able to use other techniques like subtraction techniques where you have the CVS flow rate and the dilution air flow. And the difference between the two is the exhaust flow. Maybe even taking the exhaust flow from the ECU. All of this is still yet to be discussed in the testing methods. Now, even though tailpipe raw ammonia mass is the default, there could be potential for conti-dilute ammonia mass, but the CVS design may have to be modified. For absolute certainty, you must have a heated transfer tube to stop condensation, which ammonia would dissolve in. And maybe you made other changes like the use of what's called a remote mixing tee. So in the future, we're not sure about this. It is under discussion at the moment, but continuous dilute ammonia mass might be allowed, but the CVS would have to be specified to allow that to happen and to be applicable. Now, brake dust. Brake dust is now included in Euro 7. Here is the test cycle. This is a test cycle that the brake must be a simulated road trip. It's modified from the WLTC cycle, and this is the formation. So the brake dynamometer will rotate the brake disc and apply these forces as indicated by this test cycle. I'm not going to go through the details of it. This is the equipment that applies that cycle. So this is our brake tester modified for brake dust. Here is the brake dynamometer connected to the brake disc. The brake disc is encapsulated with an enclosure, and we have HEPA filtered air, which is brought through, comes around and goes in through the brake enclosure, which is obviously rotating. Any emissions during the test is then captured and transferred into a sampling system. And there's a variety of equipment here that measures PM mass and also measures different particle numbers as well. And then you have a flow meter. So by measuring the mass emissions and the PN emissions, you can then measure this from a single brake disc, which can then be multiplied up into 2 or 4 brake discs. Now, one of the issues, of course, is front brakes tend to emit more particles because of braking effort than rear discs, but that's going to be covered in the regulation to calculate the brake emissions from the entire vehicle. So what we have then is the hardware and software for Euro 7. We have we have a combination of the test equipment down here and the automation system. So very briefly, I'm just going to go through a quick summary of our test automation. In HORIBA, we have a platform called STARS, and STARS is the basis of the majority of our test information, of our test automation systems. So we have different flavors. So for example, this is STARS for vehicle emissions testing and for STARS for electric vehicle testing. We also have a base version that does engine testing. We have a version that takes the engine test and adds on a package for heavy duty engine heavy-duty engine exhaust emissions testing, what's called the HDET, so which covers all of these certification test cycles and the R&D for gaseous and particles and everything else. Also, obviously, you've seen the brake tester. So we have a STARS that controls the brake testing system, not only measuring dust, but measuring all these other parameters associated with brake development and brake testing, like noise, vibration and harshness, durability, etc., etc., etc. So that is the test automation system for brake testing. Sitting above all of the STARS in the test cell is the STARS Enterprise system. And the STARS Enterprise system is effectively laboratory management of information. So it includes a central storage of all the results. It includes scheduling functions for each of the test cells. You're also able to configure tests and test sequences at the STARS Enterprise level that can be then downloaded into the test cell level. And finally, a new introduction is what we call the Insight. The Insight is some functional application that sits between the emissions measurement equipment and the STARS Enterprise. And this gives you live monitoring of what is happening within the equipment, monitoring the quality data, such as all of the verification like linearization and NOx efficiency test. And it also actively manages what's going on here. So you can use this for setting your scheduled maintenance and all of the support functions that are normally really desirable for emissions test equipment. And at this point, if I can hand over to my colleague Oliver Meller.
Thanks, Les. What Les outlined just then was one of the apps in Enterprise, and here's a few more. So I work in a team that's essentially looking at the existing HORIBA equipment and future equipment and trying to add smarter tools on top. So using machine learning, using the rich data that we get from our accurate measurement devices and trying to compress workflows, trying to provide extra value to our customers. So here we have an example where the EU7 is requiring RDE in the lab. And I'm going to go through two solutions that we have. One is called torque matching, which is our patented approach to bringing road test data into the lab incredibly accurately and repeatably. And the second one is digital twinning or empirical digital twinning, where we take data from a powertrain or a vehicle, and we create a digital twin of that powertrain or vehicle, so that predictions can be done very accurately for range, energy use, emissions, performance, etc. So it's worth pointing out at the start that RDE in the lab hasn't fully been defined. Les can probably talk to that in more detail. So it could be the EU regulations could request a simulation. They could request an actual replication of a test that's happened on the road, or some kind of randomized RDE. So we're not quite sure, but we think we've got quite a compelling solution to help achieve that. So let's give some context. The current situation in testing and RDE testing, I should say, is a very narrowly defined set of buckets, if you like. It's sometimes quite difficult to complete the tests, but when a test is completed, it's not necessary that the vehicle has passed or not. But in that situation, the testing is difficult to do, relatively difficult to do, but the engineering and the design of the after-treatment system, the calibration, is bounded, is constrained. So in effect, it's guided in terms of how to design a vehicle to achieve Euro 6. It's not to say that it's easy, but in the future, we're moving to this scenario where, as Les mentioned, any trip composition is valid. So that's great for testing. That means that any type of road test is effectively able to be completed successfully. But the downside is that means anywhere within the regulatory box, within the design space, could be tested either by third parties or regulators, etc. So that presents a big problem for our customers. How do they cover that entire range effectively, efficiently, and without having too many more resources and test facilities, etc. So that's the challenge that we're proposing we solve with some of these tools. If we move on to an illustration of what that could be. So if you imagine a typical test plan, are these red boxes here, and I'll walk you through that. So one powertrain family in one vehicle model at a particular traffic density, very aggressive driving, for example, and then a low state of charge at high altitude. That could be deemed to be the worst case scenario for that vehicle, for that manufacturer. But clearly there are other permutations, so less aggressive driving, less traffic, and so on, and different altitudes, and clearly more than one model and more than one powertrain family. So with just this example here, you can quickly assume, if you discretize the boundaries, 108 permutations. So that's a lot of testing potentially to do to demonstrate compliance. So what we're proposing is that customers do the testing that they feel comfortable with, perhaps the same as today, maybe a bit less, maybe a bit more, but fill in the gaps with simulation. And traditionally the challenge with simulation is believing that the simulation is true and giving you good enough data. And we think now we have a solution to bridge that gap in trust. Here's another way of looking at it. The red boxes, which are quite hidden here, could be the traditional test approach, the physical testing, taking vehicles to cold climates, high altitudes, hot climates, and the traditional approach, traditional test plan, but then filling in the gaps in between with simulation and covering the entire box. So this would be the extended EU boundaries. And one of the things that we think is compelling about this approach is it gives the ability not only to cover all the possible permutations and scenarios, but it can also highlight areas of concern. So an area which may never have been tested could flag through simulation, and therefore can be caught before the vehicle is released to sale. And I think this is particularly interesting for the legal teams within OEMs. They want to feel confident. They want to feel that there's a managed risk when these vehicles go to market. So how we propose that it can be done, it's essentially using existing test labs with a few upgrades. Step one would be to do the road testing as normal, hopefully with HORIBA's Euro 7 PEMS equipment, recording the pedal positions, recording the vehicle speed and outputs from the PEMS equipment as well. And then we have a piece of software which translates that information into a test cycle, which we call torque matching. So this is a special cycle which effectively reruns what happens on the road. The robot driver depresses the pedals exactly the same as the human driver did on the road. The MEDAS system replicates the density and the pressure as the vehicle saw on the road. So it could be high altitude or whatever. And obviously, if it's the ability to do temperature in the lab as well, you can replicate the temperature that the vehicle saw on the road. And essentially what that means is the only thing that's left after that is the torque. So the dyno is constantly trying to achieve a speed, and it's doing that by using torque. So the output of that is a torque trace, which very, very accurately replicates what the vehicle saw on the road, the loads that the vehicle experienced, whether it's wind loads or road tire loads, rolling resistance, I should say. So it's a very efficient way of achieving the replication in the lab with a very high correlation. So now that we have this torque match load, we can add it to the original test file, and at this point we can emulate the vehicle test, and you can change calibrations, change after treatment components, and even change some vehicle models, as long as the vehicles are roughly the same size and shape and weight. So good for benchmarking, actually. And that's a great solution, and torque matching is now being used in a number of our customers. But then we're taking it a step further. So now we've got the vehicle on the chassis dyno or an engine on an engine dyno, we can design a test which pushes the powertrain across all of its operating modes. So flat out or idle or hot, cold, into knock and into, just before stall, and basically create a data set, which is a training data set that gets brought into one of our neural network algorithms. It creates a digital twin, effectively a very fancy lookup table, but essentially it creates a data model of the powertrain, but it's very fast running. It's very lightweight, so it can run faster than real time, and then that can be added into CarMaker or Simulink or CarSim, one of the simulation packages that your simulation team uses. And even on a basic laptop, thousands of scenarios can be analyzed very, very quickly. You could program in a sweep of an entire regulatory boundary and get out of that a data pack which gives confidence that the vehicle at the point of sign-off meets all the regulatory requirements, or shows up some areas of concern in a particular part of the map, which the engineers can go back and quickly rectify before the vehicle goes on sale. We also think this has some uses for regulators as well, to try and cut down their workload. So we're quite excited about this solution. So this is a copy of the slide that Les showed from the idealized chassis dyno setup. So essentially we're saying, do your road testing as normal and then replicate on the dyno. So we're replicating a real world cycle, but we've got the benefit of using laboratory grade measurement equipment, the ERLAM technology that Les talked about before, and we've got the ability to do it repeatedly. So it's stimulating the ECU exactly as it experienced on the road. So that's what makes it different from a RLS road load simulation approach, for example. Clearly, the robot is more accurate than a human driver could be, and this then has benefits in terms of accurately replicating, generating the same loads, and ultimately very, very close correlation for emissions, battery usage, energy usage in general. That's a little bit about torque matching. And then empirical digital twin. Similarly, we've done it on a chassis dyno. Effectively, in this case, the vehicle acts as a powertrain test stand, and we operate the chassis dyno as if it was an engine dyno, in effect. So we design the test to make sure we've captured the entire operating range of the powertrain. We ask the test automation system to perform this kind of strange testing. It generates a lot of data. The data then gets compiled by our software into this powertrain app, and then whichever software your engineers prefer to use, they can use that and explore different scenarios. And again, create this data pack of very trustworthy simulation data. So this then opens up the potential. We're currently focused on creating digital twins of ICE engines, batteries. We're also looking at fuel cells as well, but there is the potential for other complex nonlinear systems, such as thermal systems and sensors as well. So once you have these digital twins, these accurate empirical digital twins, you can use them across different models, in different scenarios, different variants, and different departments. So ADAS teams can use a powertrain model to help improve the accuracy of their ADAS prediction, and likewise ride and handling, and maybe a torque vectoring team could look at the performance of the powertrain early stages to improve their accuracy. And once we have that, then we can highlight these areas of concern and immediately jump on fixing that, whether it's a calibration change or there's a change that's needed in the after treatment system. And likewise, this is what it looks like for an engine dyno. Design the experiment based on the powertrain, based on the use case, create the data, create the model, run the simulations, and validate back on the engine dyno if there's an issue. Here we've got the MEDAS system, which simulates altitude and temperature and pressure. And here we have an encapsulation box, so a thermal box, so we can do cold start as well. So we're more than happy to share with you how we do that, obviously, because we think cold start is going to be critical for Euro 7. And here's just a quick example. We have some engine out, temperature and NOx information. We actually combined it with a physics-based model, a basic model, ran it in RPG CarMaker, and we highlighted for a customer tailpipe NOx issue, which they were then able to fix. So we would be very happy to talk to you about how you can get this capability in-house. And clearly, we think there's a huge benefit here. So for a typical RDE program, we've estimated sort of 45 days of RDE testing, and we think there's huge potential to cut down the number of tests, the number of trips, expensive trips to hot climates and altitude areas, for example. And what you have then is a mixture of some physical testing and some validation and model creation. So the test teams work in partnership with the simulation teams. And that's everything from me. So let's have another survey. So what do you need from suppliers like ourselves? We're asking you an open question, really. Feel free to email us anything that's missing off here. But we've put a quick list of some of the major challenges that we think we should be helping you with. But clearly, tell us if we need to do something different. And we'll just let this run for a few minutes to get the responses. Okay, that's interesting. It's similar to the results we got this morning, where laboratory upgrade packages and onboard testing were popular. And I think in this session, the greater integration with simulation is slightly more popular than last time. Okay, thank you very much.
All right. Thank you, Les and Ollie, for this presentation. I hope it was very interesting for all the participants. I believe so. Now we would like to go over to the Q&A with the questions that you popped in the chat throughout the webinar. Feel free to still drop some questions that we can answer for you. So question number 1. It looks like life cycle emissions are not included here. For example, raw material mining, component manufacturing, end-of-line recycling, disposal, etc. Can you confirm this?
Yes, EU7 does not
Thank you, Les. We will continue with another question. Yeah, all right. What does Euro 7 mean for agriculture vehicles?
Absolutely nothing. They'll be covered under non-road mobile machinery, which is currently a level stage 5. So there's nothing to do with such agriculture or construction equipment or anything like that.
All right, thank you. Another question. By any chance, would the current QCIIR analyzer, so the OBS1XL00, be upgradable to measure all components similarly to the system in development?
No. Unfortunately, it's such a radical change to go from 2 lasers to 8. So that will be, it will be practically impossible to do that.
All right, thank you. Are the simulations also being studied for brake particles?
So that's a very interesting question. We haven't looked at it yet, but I think given the interest that we've had in this webinar and the one this morning, I'll be asking my team to look at it. In principle, there's no reason why not. The same process applies, so watch this space.
All right, thank you. Does dilute NH3 measurement from CVS mean heated CVS sampling is required?
At the minimum, it requires heated. It will require at minimum a heated transfer tube. It might require a heated tunnel in order to transfer the gas. On the other hand, something like the use of remote mixing tea, where the exhaust is diluted at the tailpipe, might be applicable and give consistent results, in which case a heated CVS would not be required.
All right, thank you. Another question. Do you have a timeline for when the RDE simulation system will be available?
So it's available now. So we've deployed torque matching to several customers already, and we're currently in discussions with deploying the digital twinning approach with a customer right now.
All right, thank you. I hope that answers all your question. Again, if any question is not answered, please reach out to us via email. Another question, any solutions or comments on the vehicle OBM verification and measurements?
Well, I think the solutions will come from the comparison of the OBM data with data achieved either by comparison with PEMS on the road or by comparison with emissions measured in the laboratory. The purpose of OBM is effectively to give an equivalent emissions result as to what the vehicle would be measured by PEMS or on a chassis dyno with a CVS. So that would be the verification. And so I expect that will be part of the type approval process to verify that the OBM is working within accordance with conventional measurements either on the road or in the laboratory.
All right, thank you. Another question. I would like to ask regarding the internal temperature of QCIIR. 110 degrees Celsius is lower than 190 degrees Celsius, typically used for NH3. Is there a specific reason for that?
Yeah, well, it's interesting. You have to go back a very long time to find out why 190 degrees was selected by heavy duty. And in fact, subsequent work that was done in the WLTP working group and in non-road changed that specification from 100 to 190 to 110 to 190, because it was discovered it is not necessary to measure 190 degrees for ammonia. So we have used 113 degrees. We've also used 190 if they're specified, but normally, because we get a more accurate, a more sensitive analyzer by sampling at a low and measuring at a lower temperature, we tend to use 113 degrees. There's another reason we use 113 degrees in some of the analyzers, is because if you get a high temperature, you can get a reaction between nitrous oxide, NO2, and soot, which actually will change the NO-NO2 balance. So to stop that reaction occurring, we tend to use 113 degrees if the regulations allow. And I should point out that the heavy-duty regulation that currently under Regulation 49 that specifies the use of 190 degrees is in the process of being modified to harmonize it with the light-duty and with non-road mobile machinery, which specifies 110 to 190 as applicable temperature for ammonia.
All right, thank you, Liz. Will HORIBA be ready for an upgrade of a test cell for conformity of production of M1 cars? If so, when?
I think in essence, I think we're already there. The ammonia analyzer is already available. The only thing that we need to define is how do we determine exhaust flow rate for a ammonia measurement based on a tailpipe sampling. And again, I think that's something that will be discussed in the implementing act discussions in terms of the equipment. But certainly you could use an exhaust flow meter. You could use the exhaust flow meter from a PEMS, for example, and that would work. Or you could use another type of method. But at the moment, I would say, as long as you have an exhaust flow meter that measures or determines exhaust flow rate, all you need is the raw ammonia analyzer. And effectively, for Euro 6 light duty, you're pretty much done. That's the only addition that's necessary.
All right, thank you, Liz. Can an OBS1PN be upgraded to measure PN10?
Same question we always get. It looks similar, but it's more detailed than that. There's been one of the issues is to reduce the amount of loss of 10 nanometer particles. So there's been considerable amounts of work done internally in the OBS1 PN10 that practically makes it very difficult to upgrade from 23 nanometers. I think that's basically where we are. It's a good question and one that I'm sure will get confirmed 100%, but that's my understanding at the present time.
All right. Do you have a preliminary EU7 RDE data evaluation tool, or when do you think it will be available?
When we know a little bit more about the data processing that will be involved in Euro 7. Oliver referred to the use of Euro 7 is an infinite driving. In practice, there are also discussions at the moment that to try to moderate, so it's not full throttle acceleration all the time. It's to stop people using RDE with full throttle on, full throttle off, full throttle. They're trying to put some kind of moderation in, and that may affect the data processing. But at the present time, there is no, unlike Euro 6, there's no limitation. So effectively, you measure the emissions continuously, and that's integrated into a milligrams per kilometer figure for light duty and a milligrams per kilowatt hour for heavy duty. But the actual mathematics of how those results are generated are a subject of the implementing act discussions in agvez at the present time.
All right. Another question regarding more of the legislation. So what if there is a turn off and on situation for the 2+8 kilometers emissions budget? Would it be an ECT or EOT sensor dependent?
I'm sorry, could you say the question again, please?
Yes, sure. What if there is a turn off and turn on situation for the 2+8 kilometers emissions budget? Would it be an ECT or EOT sensor dependent?
Again, I'm not certain on the answers to this. For the 2 kilometers, the 2 kilometers would have to be sorry. So what would happen is that whether whether the vehicle had been driven in a normal mode, that is with less than the average 20% wheel power during the 2 kilometer or above, will be decided at the end of the test. It's not an instant. It will be logged by the PEMS, and when the PEMS does its final data processing, that's when whether the vehicle was in extended mode will be then applied to the measurements made, if that answers the question. But so it's at the end of the test in the post-test data processing function where that will be decided.
I hope it answers the question. Another one regarding the QCIIR. Will the new QCIIR system consume less power than the current PEM setup? If not, is there a plan to extend runtime?
It's a good question. I don't know at the moment. That's why I put down to be confirmed. The issue about the runtime is a really good question. Currently, we're limited to 2 hours, but this discussion has come up several times, and the EU Commission is not favorable at the moment to setting a maximum time. So we may have to look at different battery technologies to give us more energy. Well, I mean, we really hope that the QCIIR will measure the 8 components with no more power than we currently use within the current unit. But we may have to look towards technology that we either allows a bigger battery capacity to run for longer, or we may have to come up with something that allows batteries to be switched whilst the test is ongoing. This will all be discussed in the Implementing Act. And this will be answer to a lot of questions. It will all be discussed in the Implementing Act discussions of agvez over the next year.
All right. And then what seems to be the last question for today, will SHED or SHED be required in a COP environment?
That's a very good question. Could you save that one? Because I need to go into the regulations and have a quick look to see if it is or not. It's in the annexes, and if I had enough time, I would upload the annex and have a look. I don't think it is. It's part of in-service conformity, though. Definitely, it's part of in-service conformity. I'm not sure it's part of COP, but I would need to check that. So if you can take a note of the question, and then we will confirm it 100%. Okay.
I hope for the moment this was sufficient. Again, you heard Les's answer. We will get back to you with more in-depth of an answer. All right, we're already 3 minutes over the scheduled time. I hope everyone enjoyed the webinar, and I hope we answered all your questions and concerns regarding Euro 7. If not, feel free to reach out to us or drop us an email, and we will make sure to get back to you. All right, thank you everyone for participating, and have a nice day. Goodbye.